We're now going to showcase a new product for the very first time. We're super excited because we've been working on it for a few years now, introducing ArcGIS Enterprise on Kubernetes. It's an architecture that's based on microservices, it's containerized, and it runs in an orchestration fabric. It's a new cloud-native deployment for your enterprise GIS. It's designed for scale, resiliency, and maintainability. And of course, as you can expect, it can be fully automated too. There are three key concepts I want to introduce to you at this time about this offering. The first one is how we deliver the software itself. It's packaged as Docker containers, made available via a Docker registry. These containers are very self-reliant. They are autonomous units that help with fast and consistent deployments and easy maintenance too. The next is how we run the software. It runs on an orchestration fabric, it's called Kubernetes, which is designed for cloud architectures. It's like a distributed operating system. You can manage this fabric like as if it was one cluster, one unit, making it very easy to deploy, manage, monitor, and scale. But you might ask, where did we spend and invest most of our efforts? It's to break down all the capabilities of enterprise GIS into small managed microservices, units of functionality that can be distributed and scaled massively. We architected a complete GIS system that's cloud native by design. It's made for your enterprise cloud, whether it's on premises, it's in your private cloud, or in your public cloud. Our first release will support Microsoft Azure and its managed Kubernetes environment. It's called EKS. We also support Amazon AWS, and its managed environment is called EKS, and on Red Hat's OpenShift. In a subsequent release, we plan to support Google GCP. Its managed Kubernetes environment is called GKE. Beyond the cloud-native computing aspect itself, here are some more of what you'll see in this architecture, details of how cloud-native data storage connectivity is achieved. It's very fitting for the environment that you run in. And all this can be provisioned using infrastructure as a code pattern. This architecture is designed to meet modern DevOps expectations, from architecture to operations. Now let's get into some detail here in terms of how you deploy, configure, and use. Before you deploy, you need a provisioned Kubernetes cluster, which could be OpenShift, Azure AKS, or Amazon EKS. Here you see a cluster of about 15 nodes with some attached volumes for persistent storage. When you run the deployment script, we lay down the containerized microservices into each of these pods. The first ones are for administration use, as you'd expect, like the admin API, manager, and of course the help system itself, and the ingress controller that routes the incoming calls that you see on top. Then we start configuring the system to suit your architecture pattern and necessary capabilities. In this step here, you can see managed data stores like relational, spatio-temporal, object stores being automatically configured for high availability, as indicated by the number of pods running them, like 2x and 3x and so on. Also, we have very powerful metric collection via Prometheus and Grafana. And then more microservices like a catalog to list your services, and the JavaScript API itself start appearing. And then as you notice here, the portal itself has been broken down into multiple microservices. These are the right granularity for the functions they provide, the need to scale and patch when necessary. Then you have the geoservices like maps, tiles, scenes, geocoding, and so on start appearing. Of course, you can continue to configure or use the system at this point. You can attach your own external enterprise and cloud data stores like you'd expect too. For a first demo, I'd like to introduce Markus to show us how the entire deploy and configure process is automated using a very modern DevOps pattern. It's really defining geospatial infrastructure as code. Markus?
Thank you, Jay. To get started, you will need to provision your Kubernetes cluster. Once it is provisioned, remember this three-step model to get started setting up ArcGIS Enterprise on Kubernetes: deploy, configure, and use. Let me go ahead and show you. Here in our terminal, we use the deploy script to go ahead and bootstrap our setup. This script can be used with this deployment template, which is specific to your enterprise, allowing you to easily automate across your dev, staging, and production environments. Let's go ahead and run this script. Now this script directly communicates to your Kubernetes cluster. Additionally, it runs an initial set of microservices. This will take a few minutes to finish. To help visualize what is going on within our cluster, we're going to go ahead and use the tool Lens, which is a popular open source Kubernetes IDE. Let's switch over to Lens. Do you remember that initial set of microservices that I told you about earlier? Well, within Lens, underneath this Pods tab, we have our 4 initial set of microservices. We can now proceed to step 2, the configure step. Let's navigate back to the terminal and over to our configure script. Just like in the deployment step with the deployment script, this configure script also can use a configure template. Let's take a sneak peek into our template file. We can see that we have specified a system architecture profile of enhanced high availability. Now that means that ArcGIS Enterprise on Kubernetes will be configured with both redundancy and high availability. Let's go ahead and now run this script. In the configure step, microservices are launched from storage to system and utility geoservices. Let's navigate back to Lens. And we can now see an additional microservice has been populated. This process will continue for a few more minutes. I have set up a second deployment that already has finished with the configure step. Within Lens, let's navigate over to that environment. Underneath the Pods tab, notice that all of our microservices have been successfully provisioned in this environment. Once that's done, let's navigate back to our terminal with this new environment, and we see indeed that the configure step has successfully finished. Using the 3-step model, we have just deployed and configured a production-ready, enhanced, highly available ArcGIS Enterprise ready to be used. This simple yet powerful workflow will enable your success automating ArcGIS Enterprise on Kubernetes. Back to you, Jay.
Thanks, Markus. That was really cool. What you saw was not just how simple and quick it was to get your geospatial infrastructure up and running and ready for use, but also the fact that it's highly available production system ready. It's fully automated and designed for modern DevOps practices. There's no more guessing and hoping to get it right. As you can see in this slide, you'll notice that you can also federate your existing servers to this base ArcGIS Enterprise system to suit your needs. It's a kind of hybrid model of deployment within your enterprise. Next, I'd like to talk about scaling. Say you have a dynamic map service that's going viral. You might just want to scale that alone, and you can do that here. Now I have 3 pods running the same map service. Moving on, an Achilles heel of large enterprise systems is patching and upgrading to newer versions. Usually there's a downtime if you recreate the system. As you can see here, that's what happens when you go from one version to another. This new version that we are building is much smarter. Behind the scenes, when you apply a patch or upgrade to a new version, we apply 2 techniques to reduce downtime. The first is a rolling or ramped update, where we gradually roll the new version even as we roll out the old, like you see here. In some other cases, usually when you upgrade deeply stateful microservices like data stores, we apply a blue-green update, where we create the new and switch the load balancer to the new when it's ready. These are done automatically and helps minimize downtime on production systems. I'd like to now introduce Shreyas, who will go through 2 demos. The first is how we patch and upgrade the software, and the second is how you scale your system. It's basically automated maintenance and operations. Shreyas, please show us.
Thanks, Jay. Enterprise on Kubernetes has a new manager application that allows administrators to monitor and manage their enterprise deployments. When you log into Manager, you are taken to an overview page that gives you a broad perspective of your system, including critical logs and the status and health of important components in your system. Using Manager, you can update and configure the security settings for your organization, as well as manage software licenses. But one of the most sophisticated features of Enterprise on Kubernetes is the software update process. The system is smart enough to detect when new releases and updates are available and can alert the administrator. Let me show you how. I am at build 1250 for version 10.9. I can see that there are 2 updates that are available. Let me go ahead and install one of these updates. The update process is asynchronous and allows me to interact with the system. It's also returning detailed status messages of the update process. The process systematically iterates over all the affected microservices and in a rolling manner swaps them out with new container images. This process takes a few minutes depending upon the scope of the update. I have run an update before and it was completed successfully, and my system is ready to use. In a similar fashion, I can install the latest software release in this way. Like a modern system, this entire process can be driven with code and automation. Here I have a simple Python script that's communicating with the administrative API to look at the available version of the software, the new updates and releases that are available, and then prepares to apply the update. But before it does that, it modifies the portal user experience to notify its users with a custom banner and via email. It then prepares to apply the update and then waits for the update to finish. Once the update is done, it runs diagnostics to make sure that the health and status of the system is maintained. Enterprise on Kubernetes has been designed from ground up to aid in your automation journey, saving you valuable time and energies in maintaining your deployments. So far, we've seen deployment, configure, and maintenance of Enterprise on Kubernetes. Let's switch gears a bit and take a look at administrative workflows to monitor your GIS services. In Enterprise on Kubernetes, we've baked in the powerful metric collection server Prometheus, as well as a query visualizer Grafana into the product itself. Let me give you a quick tour of the metric capabilities. Using Grafana, I have authored a dashboard that represents the usage statistics of my simple sample world cities map service. The graph on the top left indicates the average response time for the service. The graph on the top right indicates the percentage of requests that were serviced under 1 second to meet my service level agreements. Requests are currently being generated using a simple JMeter test client. You will notice that there is some load on the server, but the system appears to be handling the requests and load well. I'm able to meet my SLAs about 100% of the times. Let's see what happens if you were to increase the load on the system. To do this, I'm going to reconfigure my JMeter test client to simulate more users. The JMeter test client is a step load tool, and it takes a few moments to ramp up. Behind the scenes, Manager communicates with the Administrative REST API. The Administrative REST API issues commands to Kubernetes to scale the pods up. When the new pods are up across your cluster, they're added to your load balancer and your service gets additional capacity. Let's take a look at our dashboard. We are now seeing that the average response times for that service are spiking. That means the system and the service is definitely under load. Our SLAs seem to be dropping as well. This is a case where an administrator like me needs to be alerted. If the load is expected, I need to provision additional capacity to handle this. As an administrator, I can do this very efficiently and effectively on a per service basis. Going back into the Enterprise Manager and access our service configuration, let's look at the settings for this service. It's currently running a single pod with some CPU and memory limits. I can either grow the pod larger by increasing the limits or increase the number of pods for that service. Let's go ahead and change this to 3. It's going to take a few seconds for the new pod and capacity to be provisioned and to have it reflected on our dashboard. Going back to our dashboard now, we can see that with the improved additional capacity, our average response times are improving. We are also able to meet our service level agreements for a higher percentage of times now. So with the increased capacity, our service seems to be doing much better without impacting our client in any way. Now I'm showing you a very manual demo, but this can be very easily automated with a little bit of scripting. Using scripts, you can query the Prometheus metrics server and collect statistics on these services. You can then feed it to a simple analytical routine that can raise an alert and take an appropriate action. In Enterprise on Kubernetes, you monitor and observe as an API, allowing you to manage and scale your geospatial infrastructure as code. Thank you.
Thanks, Shreyas. That was really cool. You saw 2 examples of change management done on a live system. We've removed the uncertainties and made it kind of mundane, you could say. That's modern CI/CD and DevOps for you, benefiting from this architecture and ensuring business continuity. ArcGIS Enterprise for Kubernetes will be released soon as part of the 10.9 release. Please check it out. What you've seen today is a small peek at the many ways you can automate your GIS, whether it's infrastructure or workflows, within your enterprise or beyond.